Hi everyone, today we're going to be looking at multi-step equations. So we're going to be solving equations that have more than one step to get to the answer. This is from 2-3, and the learning target for us today is I can solve equations that involve more than one step to reach a solution. Okay, so these are multi-step. We've already done single step, and now we're just looking at the same process, just more steps involved. Okay, let's look at a couple problems to try to solve. Now, the first thing I'm going to suggest, and I'm going to insist on actually, is we're going to use what I like to call train tracks. Some people will call them other things. Some people won't actually write the lines in, and I guess I'm okay if you don't, but the main thing I want you to know is the equal sign should stay in line with each other all the way down, and that makes it very easy to see each step of the process and makes it very easy to see if something goes wrong, where it went wrong. So that's what I really would like to see from all of you when we're doing multi-step solutions especially, but really with even single step, it's a good habit to get into. But I really want to see them on multi-step equations, the train tracks. So here's what we'll do. We'll just take one step at a time and go through these and see what we can come up with for an answer. So right now in this first one we have 6x minus 22, and that whole thing is divided by 5, and that's equal to 40. So since we're dividing by 5 on this side, if we multiply both sides by 5, that will still be equivalent. Same thing we learned before. If we add and subtract the same thing from both sides to an equation, it will stay equivalent. If we multiply or divide both sides of the equation by the same thing, that will make sure that it stays equal as well. So in this case, since we're dividing by 5, we want to multiply by 5 on both sides. So we can look at this a lot of different ways, but so what some people like to do is write a 5 out here and put a little time symbol there, and then they'll do the same thing over here. Again, lots of ways we can do it, and then once we have this, since we're multiplying the top and bottom by 5, now we can just cross that out because 5 divided by 5 is 1, so we no longer need that. So what we'd have left on the left side then is 6x, and that's going to be minus 22. Again, keep our equal sign in between the train tracks, and that's why we call them train tracks. It looks just like a train track when you have the equal sign inside there. 40 times 5 is 200. And then now we're just going to do our next step. So we have 6 times x here, and we have 22 that we're subtracting away. That's going to be the next thing we're going to do is deal with this 22. Since we're subtracting 22 from here, if we add 22, that means we can make it disappear from the left side, and we're getting closer and closer to getting the variable x all alone then. So if we add 22 to the left side, we need to add 22 to the right side as well. So when we go ahead and do that, we now come up with, again, this negative, or this subtracting 22. You can think of it as a negative 22 if you want. The opposite of that is a plus 22. Whatever sign you have here, you're going to do the opposite. So if you're subtracting, you're going to add. If you're adding, you're going to subtract. So now then we'll be left with 6x on the left side. We don't have to write plus 0 because that won't affect anything, so these will cancel out, and that's exactly why we chose that number, so that it would cancel out. So that's going to be equal to now 222. So now we have 6 times x equals 222. So now we're going to divide both sides by 6. So we can do a lot of ways. We can make a fraction sign. We could do the division sign. And that's going to be equal to then 222 divided by 6. So now we can cancel these out because 6 on top and 6 on the bottom would just cancel each other out. So now we're getting somewhere. On the left, we just have x left. And on the right, we're going to have 222 divided by 6, which looks like that's going to equal, so we'll just have x equals 37. So several steps involved there, but we still ended up with what we were looking for in terms of getting x by itself, and we solved this then and found out that x is in fact equal to 37. Okay, let's look at this other one over here. Again, we're going to start with our railroad tracks. And now we're going to, again, take it one step at a time. There are usually more than one way to do these equations to solve for them. And you're not going to go wrong as long as you keep remembering to do the same thing to both sides of the equation along the way. If you do that, you're more than likely going to end up in the right place at the end. This first one, what I'm going to do is I'm going to divide both sides by 7 right away. So when I do that, then that means I can cancel these out. So I'm left on the left side with x minus 5. And still have my equal sign inside the train track. Just makes it very easy to follow the steps. 35 divided by 7 is just going to be 5. Now I have x minus 5 equals 5, and a lot of you will just say, well, x has to be 10, and we're at the point where you could really say that, but I want you to continue on and just follow the process, because a lot of times the numbers won't be this easy to work with, but if you know how to do the process, it doesn't matter how big the numbers are, you will get to the right answer. So the process is the important part right now, so I want you to continue. So since we're subtracting 5 now, to undo that, we're going to add 5. And if we add 5 to the left, we're going to have to add 5 to the right as well. So I'm going to have plus 5 here. And I was getting ahead of myself a little bit with that equal sign. That's really got to come down lower. So I'll just do that real quick. So this one stayed equal there. And then now our result then will be down here. So if we have minus 5 and plus 5, that's just 0, which is what we wanted. So we're left with just x here on the left. And on the right, we have 5 plus 5 equals 10. So we were able to do this again, and we got x alone on the left side. And then we can find out what x is equal to. In this case, it's equal to 10. So these are just 2 examples. You have more that you can practice on, but keep remembering to take one step at a time, use the train tracks, and you're doing opposite operations to undo something on the side that the variable's on, and then you do the same operation on the other side to keep it equal. And you just keep working your way through until you get the variable all by itself. Once you have the variable all by itself on one side, you just simplify what's on the other side as far as you can, and you'll be left with the correct answer. Now we can check and make sure if these are correct. What we could do is plug the answer back into the original equation and make sure it works. So let's just look at the second one for now. If we plug 10 in for x, 10 minus 5 is going to be 5. Times 7 is going to equal 35, so 35 will equal 35. It does check out. And the other one actually checks out as well. If we took 6 times 37 and then subtracted 22 from that answer, and then take that whole number and divided it by 5, we would end up with 40 as well. So hopefully these will be helpful. Again, follow the process. Take your time one step at a time, and I know you'll do great. Thanks very much for listening. Take care. We'll see you soon.